Hey everyone, and welcome back to my channel Data Engine, all things data. My name is Megha Bedi and I work as a cloud engineer at Google. Today in this video, we are diving into one of the applications of generative AI, which is text extraction and summarization. We will be exploring how to use Google Cloud's Vertex AI to summarize text and extract key information using a demo. Now, before going into the demo, let's briefly understand what text extraction and summarization is. Text extraction uses AI to identify and extract specific information from unstructured text data. For example, your articles and reports. Think of it as pinpointing key details, like what are the names involved in the article, what are the dates, what are the important keywords, and finally structuring them. Now talking about text summarization. Text summarization uses AI to condense large amounts of text or data into concise summaries while preserving the core meaning. It's like getting the too long, didn't read version of an article instantly. In this demo, I have used a JSON as the desired output format. So this is my sample input and this is my sample output. My input is a very large condensed paragraph, whereas my output has the key information extracted and summarized well. So I hope text extraction and summarization is clear. So let's start our demo. In this demo, we'll be working with some powerful large language models, LLMs, that can understand and process text. For the sake of the demo, I have taken news articles to showcase the text summarization and medical transcripts to showcase text extraction. So diving into the code, first thing first, let's get our environment set up. We'll be using Google Colab for this demo because it's free and easy to use. If you are following along, make sure you have a Google account and access to Google Colab. So when you'll go to Google search and type Google Colab, you'll get notebook. If you click on the new notebook, you'll get the same UI that I'm getting, and then you can start coding out. Now, since we will be using Google Cloud's Vertex AI service, you will also need to have a Google Cloud account. You do not need to do anything. You just need to have a Google Cloud account. The rest is taken care in this code. So let's start with the essential code. This is the first line. This is the first line from google.colab import auth.authenticate user. So this is how we give Colab permission to access our LLM model, which is hosted in Google Cloud Vertex AI. It's like giving our AI assistant the keys to the library where all the powerful language models are stored. Right? So we have Google Cloud's Vertex AI platform where our GenAI LLM model is already hosted. So I have not done anything in my Google Cloud project. All the models are pre-built there. I haven't created any model, nothing. The model is just there. Now, next up, we need to install the Vertex AI library. This is what lets us communicate with Google's AI platform. So think it of as installing the software that allows us to send requests to our AI assistant, right? So it's like we are communicating with the Google Cloud's Vertex AI platform. Next up, we need to install the Vertex AI library. Now, we also need a few other helpful libraries for things like handling data, managing files. So don't worry too much details here. You just know that these are like tools that help our AI assistant do its job more effectively. So these are just the import statement for the relevant packages to be installed from the AI library. So once we run this, then the next step is providing the project ID and location, right? So we need to tell our code which Google Cloud project we are using and where our AI models are located. So this is important because it's like giving our assistant the address of the library. We know our models are hosted in the Google Cloud project. Now we need to provide the address of that project, right? So just give your project ID and give the location. Location can be anything, wherever you want your model to be hosted. Okay, now with the setup out of the way, let's now work with our core logic. So this is Vertex AI LLM model to extract information from news articles. So the predict large language model sample function, this particular function you're seeing here, it handles the core logic of sending text to the LLM and getting back a response. In this function, you can see some of the key parameters that are being passed. So it's very important to understand what all these parameters mean actually. There are some generic parameters, which is project ID, right? This is a Google project ID where your LLM models are hosted. Then model name. So here model name means your LLM models are do also have different kinds of models, right? Here we'll be using text bison model, and there are a lot of different models as well. So you can specifically mention what model exactly are you using for LLM. Next field is the temperature. The typical value of temperature ranges between 0 and 1. So basically this controls the randomness of the output, right? The higher the value, more creative your output is. For example, if you give the higher temperature, 0.8, let's say, you'll get more surprising and diverse outputs. And let's say we give lower temperature, for example, 0.2, you'll get more focused and deterministic outputs, right? Then the next parameter is max decode steps. So this parameter is used to limit the length of the generated response. It specifies the maximum number of tokens. Now the tokens can be a words or subwords. This maximum number of tokens the model is allowed to generate in its response, right? So let's say if you give 10 tokens, right? So your length of the output will be limited to 10 or around that, right? If you give 50, your length will be slightly more, right? So max decode steps basically helps limit the length of the output. Next parameters are top P and top K. So top P and top K are more advanced parameters that fine tune the text generation process, right? So top P actually controls the range of possible next tokens the model considers, right? A lower top P value, for example, 0.3, means the model will only consider the most likely tokens, resulting in more focused output. So basically, it's like a probability. Will have more likeliness, will occur more. So this will result into more focused outputs. Now, going to top K, top K is the number of most likely next tokens the model considers at each steps. So this basically influences the diversity and focus of the outputs. So these are certain parameters we play with. Then is the content. Content is basically the input that I'm providing to the model. Here I'm providing news article and medical transcriptions as my content. Then its general location where the model is placed, and then tune model name. You can give any name to this, right? And then we are just calling this get tune model, and we are just passing these parameters to the model, right? So in simple terms regarding this parameter, you can imagine the LLM is your writer, right? So these parameters are like giving your writers instruction. When I say content, so you are basically providing the topic or the story idea. When I provide temperature parameter, so you are actually telling your LLM or your author how much creative freedom your writer has. When I'm providing max decode steps, I'm actually providing the maximum length of the story. When I'm providing top P and top K parameters, so I'm actually instructing how the writer chooses their next word, whether they are just playing it safe, like common words, right? Or they are taking risk, they are introducing new different words, right? So by adjusting these parameters, you can actually influence the kind of response you get from the LLM. Now that we have understood, so let's go to the fun part, right? Fun part is working with LLMs. Like, so before jumping with the LLM code or everything, let me explain the crucial concept, which is known as prompt engineering. Prompt engineering, it's not a big thing. It's just all about crafting the right instructions for our AI assistant. So whenever you talk to you have seen in the movies, you talk to the robot, you give instructions, right? So similarly, we have to give instructions. So these instructions should be clear and have the specific direction so that your AI assistant knows exactly what we want it to do, right? So a very good prompt has three main parts: role, context, and task. We tell the LLM to assume a role, like, we want it to be a news anchor, right? If we want it to be a medical analyst in this use case, right? Then we provide a context. We provide a context, which is basically a text we want to analyze. We provide more details around it, what actually we want. Then we clearly state the task, right? Task, like you do the summarization, just put it into 2 lines, you just make it more professional, all of that, or extract the details and so on. This is the task we do. Now see this prompt engineering role, context, task in action. We can see this in action in our code. So first use case is the news summarization. And coming in onto the news summarization, here you can see that I have given a very long and condensed news article, right? Now it will be very difficult for me to read this out and get the information within 30 seconds, right? So what I can do is I can just provide a prompt to my LLM and get the output, or a summarized output. I need to summarize this, right? Now we'll see how different kinds of prompt, or how a good prompt engineering helps in getting the good output. So this is our beginner's prompt. What I'm doing here is I'm just providing this instruction: summarize the news article, and I'm providing the news article, right? Here. And this is the text bison model that I'm using. So this is a type of LLM model that I'm using here. You can use different other types of model. So if I run this, I get this big paragraph. So it is definitely, it has condensed my information, but still there are a lot of lines to read, right? So this is very beginner's prompt. It's like below average output that we are getting here, because our prompt is like summarize the news article. That's it. Now going on to the intermediate prompt, right? If you see here, I have given this prompt: summarize the news article in a very short paragraph with a few sentences. Now, here in the above prompt, I saw that there are a lot of sentences, right? Which is why I have improvised my prompt and said that I want it in a very short paragraph with few sentences. So let's run this. Now you can compare the above response with this response. There are a lot of lines. They are now in this response, it's slightly less. So I have improvised my prompt by giving more context to it, giving more details to it. So this is kind of an average response. I still need to, read a lot here. But if I just want to the point, I can just go to this pro level prompt. Here, if you see, I have given the proper context with details, saying that I'm a news anchor who does daily bulletin. Because of shortage of time, I'm going to create my bulletin using news article and so and lot of things. Then I say create a single line bulletin which is impactful yet conveys the news. So here I'm actually telling this LLM to create a single line bulletin only. Now if I run this, you can see that I just got a single line. So this is much, much easier, like compared to this condensed whole lot of summary, and I get a to the point news bulletin, right? So it says in a dramatic turns of event, Ajit Pawar has joined hands with the BJP, leaving his uncle Sharad Pawar and the NCP in a lurch, right? Now, I'm sure you have seen this guy, right? This news anchor. Let's say if you want to bring in those details into your output, how can you craft your prompt? You can give it more context, you can give it more adjectives, right? For example, in this prompt, right, I'm a very emotional news anchor who does daily bulletin with awe and anger. Like awe and anger, I want to create an emotional impact on the audience. Single line bulletin which is full of wonder, surprise, anger. Also add exclamations in the news, right? So if I run this, I'll get this response. Ajit Pawar, nephew of NCP chief Sharad Pawar, joined hands with BJP in Maharashtra, leaving his uncle fuming, and then exclamation mark. So it gives a very impactful news bulletin. Now you can see, like with the prompt engineering, with a different kinds of prompt, we see a very drastic difference between the output we have gained. And you can also actually see that I have given the same, nearly same parameters, right? Now come, so this was the new text summarization part where I have just summarized the text according to my needs. The next use case is the text extraction. Now for text extraction, I am giving the medical transcript of a patient as an input. So this is a transcription of a medical patient. Now what I want to do it, I want to extract the meaningful information. I want to extract the information of a patient. So I give a prompt here, extract details about the patient and medication in JSON format. So my desired output format is the JSON format. So if I run this, you can actually see that this whole lot of information. So you can see that this particular transcription had a lot of words in it. Many were useless, many were actually key phrases, keywords, right? And here in the JSON format, we get the to the point information about the patient. Name is John Doe, age, gender, height, weight, BMI, allergies, if at all any medications, right? So we extracted the meaningful information from a text. Now this is my another prompt where we say extract details about the patient and medication in JSON format, valid. And if we, let's say we want specific fields, right? We just want gender, we just want temperature or blood pressure or these particular fields. So I can actually mention that in my prompt. So if I run that, it will basically give me this exact those specific fields: gender, temperature, blood pressure, diagnosis, all of that for that patient. So this is the power of GenAI. This is the power of LLMs, which actually condenses your large text into summarized reports, or it can extract a lot of different information. So this was just 2 use cases of GenAI. I hope this might have helped you and you understood. So this is all, guys, for this video. Please do not forget to like this video. Please subscribe to my channel to get the latest videos. Thanks for watching.